Hey guys, welcome back. In the last lesson, we looked at how joins work, and we looked at fragment replicated join as well. In this lesson, we'll talk about skew join and sort merge join. Let's move on to the skew join. Let's say your boss asked you to join two datasets for some analysis, and he also mentioned to make the join as efficient as possible. Looking at both your datasets, you realize both datasets are huge and cannot be fit in memory. In that case, fragment replicated join is out of the question. So you cannot use that, and hence you decided to run a regular join. And you're noticing that your job progressed very well, but now your job is stuck on one or two reducers for a long time, and it's affecting your overall execution time. What do you do now? What actions could you take to satisfy the expectations from your boss? In this scenario, your data set might be skewed, and skew join might help. Let's first understand what does it mean to say the dataset is skewed. Let's take our stock dataset and assume our stock dataset have records for Apple. Apple made their initial public offering in 1980, so we will have records from 1980 for Apple. Now consider Facebook. Facebook's IPO was in 2012. So Apple would have far more records than Facebook in your dataset, correct? And when compared to Apple, Facebook only has a fraction of records. When you use symbol as the join key, you can say that the data is skewed because your data is not evenly distributed for the key, which is the symbol. And since the join key is symbol, and by MapReduce convention, all records for a key should go to one reducer. And this means you will have one reducer that will be overloaded with Apple's data and will take a long time to complete. Whereas the reducer which was assigned with Facebook's record will complete sooner. Fortunately, Pig offers a solution to this problem. You can introduce the keyword using skewed like this right here in your join instruction to enable skew join. Let's now look at how skew join works behind the scenes. Step 1. A MapReduce job scans or samples the second dataset or the rightmost dataset in your join. In our case, the stocks dataset. And identify any keys that have data that is too large to fit in memory. How does Pig know what is too large to be fit in memory? There is a property to help. Pig.skewjoin.reduce.mem usage specifies the fraction of heap available to the reducer to perform the join. The default is 0.5, which means Pig can use up to 50% of the heap space. And you can also specify a different number, and you have to experiment to see which number suits well for you. So here in step 1, Pig is analyzing the stocks dataset to see records for which key would exceed 50% of the heap space. So that is step number 1. In our example, let's assume records for Apple would take up more than 50% of the heap space, and this job will identify that the dataset has a lot of records for symbol Apple. Now, step 2. The second MapReduce job will do a standard join operation for records with key that were not identified in step 1. So in our example, records for Facebook will be joined the regular way, and hence all the Facebook records from the stocks and dividends will go to reducer 1. Similarly, if key Tesla TSLA is not identified by the previous step, that is by the first MapReduce job, the record for Tesla will be joined the regular way as well, and all Tesla records from both stocks and dividends will be sent to reducer 2. So on and so forth, right? So now step 4. Those keys identified as too large are treated differently. And there could be multiple keys that the first MapReduce job could identify to have a lot of records that may not fit in the heap space assigned. Based on how many records were seen for a given key, Pig will split those records across appropriate number of reducers. The number of reducers is chosen by Pig's estimate on how much records can be fit into memory. So in our example, Apple records from stocks will be sent to multiple reducers, and Pig comes up with the estimate. So looking at this illustration here, that is records for Apple being sent to multiple reducers, can you see something strange here? The strange thing is, what you're seeing here is an exception to the MapReduce convention, that all records from the same key should be sent to the same reducer, and it is very important to note. Step 4. Records from dividends table with Apple as key would be duplicated and sent to all those reducers that is dealing with Apple, and the join operation will be performed across the reducers. Skew join is possible with both inner and outer joins, but only possible with two tables, and only the second or the rightmost table is sampled. So you have to position your dataset properly in your join instruction. If you feel a dataset is skewed and needs to be sampled, position the dataset at the very end, that is, at the rightmost position. The most important thing to note is that skew join breaks the MapReduce convention, that all records from the same key must send to the same reduce. There is also another operator in Pig that breaks this MapReduce convention. Any guesses which operator is that? It is the order by operator. Order by operator also distribute the records with same keys to more than one reducer. Now let's see the skew join in action. So here is a join instruction to do a skew join. All we have to say is using skewed and make sure that the dataset that we want to sample by the first MapReduce job is placed at the right hand side. So before we execute this join instruction, let's load both the datasets. Let me take stocks first. Now dividends. Done. Now let's pick up the skew join instruction. Let me do a limit operation. Let's wait for the job execution to complete and let's then review the job. So now the join is complete and here are the results. So let's go to the very top and review the job. The first thing to note here is Pig features used in the script, skewed join. So which means Pig is executing this join with skew join optimization. So if you scroll down a bit, you would see another important piece of information. So here's another important detail. Reduce phase detected, estimating the number of reducers. Let's say our stocks dataset found a stock key XYZ to have a lot of records which would exceed the heap size. In that case, it is estimating the number of reducers that the records for stock symbol XYZ would need. And the last piece of information to look at here is this, a sampler. So this job basically sampled the stocks dataset to identify keys which would have records that may not fit in memory. And lastly, this job is responsible to do the actual skew join. That is it, guys. That is our skew join operation. We have looked at two kinds of joins so far, fragment replicate join and skew join. Let's look at another kind of join, sort merge join. You can use sort merge join when both your input datasets are sorted, and this is a mandatory requirement. The reason this is a faster join is because the entire join operation is done on the map face itself, and you should use the using merge hint to indicate Pig that you're willing to do a sort merge join. Take a look at the illustration and follow the steps. Step 1. Pig will first run a MapReduce job that samples the second input, which is the dividends dataset, and build an index for the dividends dataset. It will look at the first record of each split and will record the number of split and the value of the join key column from the first record in the split. For example, let's say we are joining by symbol key. Then the MapReduce job will look at the first record in input split 1. Let's say the first record is apple, then it will record the index entry as 1 apple in the index. Remember, the dividends dataset is sorted. Then the job picks up the first record from split 2. Let's say it is a record for 4, so it will record 2, 4. Now it will go to split 3. Let's say the first record is GE, then 3 GE will be recorded. Assume GE has a lot of records and the records for GE is in both input split 3 and input split 4. So the first record in input split 4 is GE as well. So the job will record 4 GE in the index. You get the idea, right? Now let's go to step 2. Step 2. Pig will then run a second map-only MapReduce job that takes up the first input and start processing. In our case, the first input is the stocks. In step 3, each map reads the first record from its assigned input split from stocks. It takes the value of the symbol and it look it up in the index and pick up the corresponding split from the dividends dataset. In step 4, the second map-only MapReduce job will only look at the appropriate split from the dividends and do the join in the map phase itself. Just to clarify things a bit, I'm going to ask you a question. Let's say you're processing input split 1. And the first record in input split 1 is for symbol GE. Now looking at the index, you have to pick up the appropriate split from the dividends dataset to be sent over to the mapper to do the join. Now that the symbol that we are looking at is GE, and from the index here, which input split would you pick? Would you pick input split 3 or input split 4 to be sent to the mapper to do the actual join? Are you saying input split number 3? Think about that for a second. Remember, to build the index, we only looked at the first record of each input split, which means records for GE might have very well started in the second input split and went all through the third and the fourth input split. So you should always pick up one split before the actual index entry. So for symbol GE, split 2 will be selected and not split 3. So split number 2 will be sent to mapper number 1 to perform the actual join with input split 1 from stocks. The mapper will scan all the records in the dividends dataset from the beginning and ignore any records other than GE because input split number 2 definitely did not start with GE because it started with 4. And once it reaches GE, it will start performing the join. As long as records from GE are being processed from the stocks dataset in input split 1, the mapper doesn't have to look up the index again. Similarly, when a mapper is processing records for Ford from the stocks dataset, which input split from the dividends do you think will be picked? Split 1 will be selected and not 2. I think you get the idea. Only inner joins are possible and only 2 tables are allowed in the sort merge join. So here's the instruction to do the join. The only difference from this join instruction and the other join instruction is the hint, and to do a sort merge join, you will say using merge. Remember, I said both the dataset should be sorted by key to do the sort merge join, and that is a mandatory requirement. Both our stocks dataset and dividends dataset are not sorted by key, so we cannot perform this join. But the important thing to understand is the concept behind how the sort merge join works. So when you have a sorted dataset, you can easily apply the join and get a good performance. So in this lesson, we covered skew join and sort merge join. Wow, that was a lot to take in from the last 2 lessons, isn't it? I know there were a lot of concepts to understand and comprehend. I would suggest you to watch the join optimization lessons again and try the instructions in the cluster. And do not hesitate to ask questions if you have any. With that, let's wrap this lesson. See you in the next lesson.